identification and in the EV project. One is the risk identification means to sort out the number of problems or what are the obstacles while executing the project. What are the risks? We need to find the possible problems, okay, that could affect. And that what can we do and what can go right, which will be that we can do. Mm. Then what can we do, and what are the foremost step in the understanding the project management, and prevent surprises. If you know early the problem, then it prevent from the surprise that you can quick. And then the plan ahead. So you can have a backup plan. For example, few employees will not be absent, so who will be replacing those employees? And starting from all kind of, for example, this battery, whatever the batteries you got, it is not working. So you may have any other alternative sometime. So you can have a backup plan for the mitigation of the strategies. And then increase project success rate. That means that you must identify that how we can quickly enhance or higher the chance of success, and improve stakeholder confidence that client trustee appreciate the project fee. Also, when they come, they must appreciate, oh, this is very nice, the development is very nice. So that is how they can appreciate that one. Then this will go throughout the world. So that will give you the confidence that yes, client has this project is going to be a successful project. And then we have uh, make informed decisions. Actually, all the decision you must make. So knowing risk help in choosing the correct technology and vendors and schedules and resources. These are the very important thing, that if you know that this is going to affect on the development process, so you need to choose the correct technology first, and then vendors who can supply them, and schedule and resources. That gives you. If you see, risk identification begins at the beginning of the project during the planning, project kickoff or requirement analysis. One should understand what are the risks. And during the starting of the project only, for example, we have started developing that. Initially, first we start that the magnets will require a lot of time. It will come from somewhere China or from other places, and while coming also some magnet may be broken also, you don't know while transportation. So all these pros and cons in the project execution we try to analyze first, and once we analyze this, then we try to execute that one. We try to we try to keep them improving this one, so that how we can be and then we can have, oh sorry, then repeatedly throughout the project, and you can go one after another. You can the project, whole project, these changes at the project progress. Many times, like I'll tell a story. One boy was going, and he was thinking that while going from a one village to another village, there was a river. In that river, this boy thought that there will be lot of water. So he made all this arrangement, and when he reached near the shore of the river, and he saw that the river water is has river has very small water which you can. So when you start the project, and you by that time if you see, you will see that this project are the uh, this project is going. It has a lot of challenges, but slowly you will see while executing the project will becomes very easier. So that is how. Second one is that when you repeatedly go on executing the changes, the risk change the project progress, and whenever there is a major change, for example, new technology added, or the scope is changed. Sometime we are giving guidance to PhD students, and after some time, the students they used to that maybe particular research is already been well defined. So we change the sometime problems that technology, so it changes. And then we have the scope changes, mm, and the scope of the project changes sometime. And then maybe new contractor came, also that one. And so this is actually uh, new contractor came, and you can see he doesn't know anything, and he started. And then budget reduction sometime the government or some this type of project, you will find that there is a reduction in the budget. And then regulation updates, what are the regulations, and that can be updated. So the risk, the identification is a continuous process. So that is uh, that is what the this continuous process. Okay, this identification, and it is not a iterative, not a one time. This is go on in throughout the project when it is under execution. And then effective risk identification needs multiple perspective. One is first thing is that very important thing is the project manager. So who is actually the project management manager is actually in the responsible. He must have a clear understanding of the project. Oh, this is we are going to do this much. So that identification one must do. So one is that project manager who who knows the overall project, and project manager also uh, uh, so someone is the project manager is the execution of the project, he will look after that one also. And also wherever there is difficulties, he will go, and uh, he will also take care that one. So that way this whole uh, the system of this understanding is will be the project one can execute. Then second one is the technical team or the engineers who support for for pushing this project, actually, once who developing this project, and they are designer as well as the executor in the field level. And according to the scope and that project objective, according to objective, this engineer technical team can help out. And then they identify business or customer related risk. And once you identify the business or customer related risk, what are the this customer satisfaction? And that is why we have quality control in the quality control department, by which they can give you good benefit to the customers. And then we have uh, external expert, like identify the industries, regulatory, technology, because the industries are required to take this to a level of uh, the level of this industry, because the industry for making in a lab prototype and taking to industry, there are a lot of steps to be followed, because most important is the reliability in the industry, and which will give you more analysis or more design aspect. And the industries, they can also help to build also. For example, many times we may not able to do that, and industry will help us in building our system. And then regulatory board, which will give you certification, and according to standard, whether you are able to do these things. And then technology and risk, that also come into the existence. What kind of technology you are going to develop, whether that technology is available in India, or if it's not available, how to borrow that one. There are a lot of risk associated with that technology also as well. Then suppliers and contractors, and these suppliers and contractors are to identify the procurement and delivery the risk. Okay. And the end users identify usability or acceptance risks. Okay. So risk identification is a team activity, not an individual task. So this is so it is mainly team activity. So whole team, they must be engaged in this activity, and individual task will be that is not required. So that is how the risk identity is a team activity. So how to identify the risk? What are the methods? First method is a brainstorming, that you come together and discuss whole project, and accommodating everyone who is associated with the project. They should be part of the this. For example, you know the Thomas Edison and the Tesla story. So whenever there is a DC current development or DC generator and feeding to that DC, and that time the Nikola Tesla used to give some tips to Thomas Edison, Thomas Alva Edison. But Thomas Alva Edison, if I determined for only DC, and actually he who has invented the AC, and he wanted to give some suggestion, but Thomas Edison was very adamant that what you know actually. So whenever there is a discussion in their group, brainstorming session, always Nicholas Tesla will give some kind of problem, and that problem can become the one of the so because of not accepting the brainstorming, so the Thomas Edison became one of the isolated researcher. So that is why the team must sit together and discuss the entire project, and useful for new projects. If there is a new project, it is very useful. And there are, if there is an unclear requirement, for example, you speak something, there is not clear requirement what you required and what you are going to do, that is not clear, unclear requirement. And then creative solutions, if we can develop the some solution which will be creative solutions. And this brainstorming session can also sometime give you the clear cut how to proceed to develop the project step by step. So there are few checklists. One is the past projects. Second one is the industry standards. Okay. So what is the industry standards? Then we have a company database, and then this company database you can have many answer or many experiences. So they will give you how this project was moving. So that is called the detailed project review report. Okay. So company database may have some kind of project execution strategies, methods by which you can get many help in that regard, and that will give you also more understanding, and also that will help us in the to go take the project up to industry standards. Then expert judgment. The for example, I'll tell you one that I have seen in ISRO. There was a scientist. So he tried to develop the model for cryogenic engine, cryogenic part of the engine for hauling the jet. And then he has developed a matrix which is 100 into 100. And then he came back and gave that one to one of the engineer in this, one of the scientists. The scientist made that 100 into 100 matrix just to 3 into 3 matrix. So you will astonish to see that how one can 100 to 100 matrix could able to make 3 into 3 matrix. So that is how they call the expert judgment. Experts, they can do very quickly, which we generally cannot do even the computer by using the computers. That is, who are the expert judgments? That consulting experts. One is senior engineers. Second one is the consultant. any consultant you can hire, or he can give you the guidance. Then domain specialists and experts can identify risks that beginners may miss. Yes. Many initial states when you are going to do or execute a project, and in the initial state, many things will become very redundant. That is how the you take the expert, and they will give you that you can go like this, and make it. uh, Then method 4, is the SWOT analysis. SWOT analysis. SWOT means strength, weakness, opportunities, threats. So this is your this. So strength is, what are the strength the team has? What are the strength we have in the procuring the material? That is you need to evaluate. That strength will give you the direction, the proper direction for the project. Maybe that direction may be uh, the direction may give you more insight or more depth of understanding. So this the SWOT analysis is that one is the strengths, and you can understand what are the weaknesses, where we are weak, which part. For example, you know that when there was a war or fight between Duryodhan and Bhima. Duryodhan is a very, because Gandhari saw Duryodhan in the full in the and Gandhari asked Duryodhana, you come please with naked. And Gandhari opened her the eyes, and Gandhari thought that my son will become the very strong, nobody can kill. But Duryodhan covered his private part, other part. So immediately Krishna and Bhima understood that here is this weak point. At this weak point, we can break. So, in any project execution team or any project execution limit, there is always a weakness lies over there. And you must have the knowledge for that one. Later, you should not lament or you should not worry that why it has happened. And then opportunities. And what are the opportunities we must understand to take? For example, that you are going to have some kind of converter, or somebody told that, well, please take this converter and use it, and then you give. So when you use it, you will understand what are the demerit. That is why the opportunities are very important. Then threats. Whether I am developing this motor or inverter, whether it is working, it will work or not. That is threat. So you can see that the positive and negative risks are always there. What is the root cause? Root cause analysis. That root cause means to go in deep into the root or the problem root and why it can happen. And it is useful for technical risk. Then method 6, interview surveys also you can do. You can interview and survey for clients improvement. And then stakeholders into what they require and team members. And this step is very good for identifying hidden risk. So the design or the development of this one is coming. That is why good for identifying hidden risk. Then assumption analysis. Every project is built on assumption. Vendor will give in the time. All environmental condition will be all right. If that assumption fails, that is called the risk actually. Risk occur. Then method 8 is a flowchart and process mapping. And what are the mapping is bottlenecks, then failure point and complex interface. Complex interface means no independent development. So that is what. Then method 9 is lesson learned. Studying risk from the previous project ensure past mistakes are avoided. Successful strategies are prepared. So, what are the types of risk? One is the technical risk, like technology failure, design error, or coding problem. For example, we were designing in JMEG one software, the motor, and the computer crashed. So, when that computer crashed, then that software also gone. So whatever design we want to deliver, immediately that complete system is collapsed. So we have now risk developing the same technology with the help of that one or with the help of other technologies. First one, technological failure. Then second one is the design errors. Like we thought that, oh, my design will be like this, but the design error come and we are not able to execute that. So the design error and the coding problem. Sometime coding problem takes place and you find that this coding sometime give lot of error and sometime we are not able to have compatibility according to system design. You have developed a system, and whatever things you have developed, that is not compatible. That is also there is a risk. Then schedule risk due to manpower. For example, in our IIT, when you want to develop any project, so you have to wait for 6 months to get a JRF. But you will get a JRF by advertising. But actually, if you want to get a good JRF, you have to go for the so that is why delay due to manpower, and then approvals. It takes long time. These approvals take long time. And dependencies. We are dependency in the many. For example, if X1, when he will finish his work, then only I can start. So we are dependent on each other. That is why it is called dependency. So the schedule risks are delay due to the manpower, approvals, dependencies, etc. Then we have a cost risk. There may be, as the time delays, your cost will go high. And that is what budget overrun and material cost increase. Then resource risk, like skill shortage, team turnover, and sometimes lack of tools. It is not available. So there is some limitation. For example, we had developed a motor, and it was not available, the software in IT partner. So you have to send somewhere that go and do this. And the stakeholder risk, then first thing is conflict. And if the unclear expectations, and then we have resistance to change. For example, you want to develop something and they don't want, no, I require this much only, because there are few limitations in this one. So whether there are a few conflict, that whatever the requirement, and unclear expectations. And then we have resistance to change. So that makes little. Then regulatory risk. Suddenly new rules came for the automobile industries, and the regulatory risk takes us to different altogether. And then new rules, regulations, sometimes government changes, and they put another rule, regulations. So these rules and regulations are very, there is a, then compliance issues, that the new rules and regulations, whether we have developed. For example, initially CFL came. I remember it replaced nearly all type of bulb. Then after CFL, the LED came. They are replacing. But if you see that new rules come, as well as there is a compliances issue. The power supply you develop for CFL cannot use the same power supply for the LEDs. So that is why there is a few compliances issue and a few governmental approvals. For example, the standards or the thing need to be approved by the government. Then sometime the environmental risk, that is weather conditions and natural disasters. Hmm. So sometime you see, I remember there is one company in Chennai, and Mr. Raghavan was running that company, EV company. He had small. So I have seen once there was a heavy wind and rain, that the whole company is critically damaged. So weather conditions also another thing, and natural disasters, that also affect on the in the development of this project. And then operational risks, sometime the process fail or poor coordinations between the among the people, among the system, the poor coordination or equipment breakdown that you cannot do. For example, I have a gosala where 2000 to 100 plus cows are there. So what happened, where we purchased and procure a component, and that component has affected to another component, and finally that completely the engine or grass cutting engine became dysfunctional. When they became dysfunctional, so what we will do then? So then we have to send that back to Jalandhar again. We have to wait till it has come back. Yes, that is the risk factor. Yes, अभी नहीं, क्लास मंडे को मिलो. So after identify risk, what are the next steps? First one is risk analysis. You have to analyze the risk, probability, and how it is like this, and what is the impact on this one. Impact is how big the damage is, how, what will it will affect, how it will affect that, and prioritize the risk prioritization. That means that you have a risk matrix, and that risk matrix will give you what prioritize, which one is we are going to do that. And then heat map is a tool like this heat map will give that what is the maximum risk, what are the maximum risk in that one, and risk response planning to avoid to mitigate and transfer. For example, if we have let me take you this. So if we have, this is our time t, and my power distribution, it comes, it may be, this is the morning 6 o'clock, then this may be around 12 o'clock, and this may be around 6 p.m. Here it is around 12. So if you see, maybe the power will be at this point, it will be lower. 6 point, it will be increasing. So if you see here, the average will come something like this. where is your color? Okay. So average will be something here. It will come. Maybe this is our average. So what we will do, we will see here that here you have a very peak in this. So what we do here, this is a peak of this one. Now this I want to shift here or there. So you can shift here, for example, little like this. So if you see this maximum prioritize this thing, you can transfer this peak to somewhere in this region or in this region. That is why to transferring this one nowadays in a microgrid system, we have additional storage system or inertial storage system by which you can really mitigate this whole peak type of thing and make it like a simple thing. And transfer, mitigate or transfer, then accept this one. And then you exploit this. What are the and risk monitoring and control track risk throughout the project. Okay, you control track throughout the project. You track the risk. Okay. Now the risk identification process is it is continuous and it is team based and also structured and critical for project success. So this risk identification gives you what are the gives you to you the what can go wrong. In a very complex project, you can stuck out what can go wrong. Why it happened? Why it happened? How do we detect it? How do we detect it? Who is responsible for this? And when do we identify risk? So these are the things we are going to answer. Then this is the risk identification process. That is the start the process. Then understand project information, info, like scope, goal, budget, stakeholders, etc. And then collect the input and data, like documents, contract, past projects, etc., etc. And then use identification tools like brainstorming, SWOT, and etc. Then identify all possible risks. So technical cost and scheduling, schedule, etc. and document risk in the risk register. You must maintain the risk register, and the review and validate the risk, which is very prominent, and what are the important of that one. And then we have update the risk and finalize the risk identification. You update that. And then finalize the risk identification. Then you go for the risk analysis stage. You can now analyze the risk. So, what is the risk analysis in the EV project? This is the process of examining each identified risk to understand what is the probability that it will happen. What is it? And second one is how serious the impact will be. That is the impact and severity. How serious the impact will be. And how urgent it is, priority. How it is so urgent. That is why the risk analysis, they give you that what risks are very, very dangerous, or what risks are very, then what are the impact and the severity, and what risk is the priority we should take. So, then risk analysis help in the project team to prioritize the most dangerous risk. To prioritize most dangerous risk and use resources wisely. Do not waste time on low impact risk, which is a very important thing. Do not waste your time. Make better decision, clear understanding and planning as well. And then prevent big surprises. So, you solve the risk before they appear. Before they appear. And that is why Dudhena Chattva. Before that, you can mitigate. And then improve project success. Project with proper risk analysis, stay on schedule and on budget. That is why the proper risk analysis need to be understand that to improve the project success. Now, so when the risk analysis done, first one after risk identification you can do. During planning, when we plan, that time only we should do this risk analysis, and repeatedly during the project. Because risk can change during the project, that risk can change. So, who will perform the risk analysis? First is the project manager. Second one is the technical leads. Okay, project manager is more responsible for this, and technical leads. Third one is final, the financial people or financial component analysis. Those who are handling the finance part of the project, they need to. Then who is a consultant or the subject matter experts, they should. And then the stakeholders. So they need to perform the risk analysis. So who are they? Project manager, technical lead, financial analyst, subject matter expert, stakeholders. And because they have a different, people have a different impact on the project. How risk analysis done? One is step by step, that list all identified risks from the risk register you created earlier. Then assess probability rate, how likely each risk is to occur. For example, that high is nearly 80 to 100%, or medium is 40 to 79%, and low is 0 to 39%. Then assess impact, the impact area, where it will impact. First one is the cost. Second one is the time. That what is the, and third one is the scope. Then fourth one is quality. Fifth one is safety. And sixth one is the reputation. Then calculate the risk. So risk score is equal to probability into impact. This will so how dangerous the risk is. Risk kitna dangerous hai. To create a risk matrix, plot risk on 3 into 3 or 5 into 5 matrix. And high probability, high impact are called the red zone. If you go to any quality management institutions, they actually have this, for example, in HL, we had the quality department. And they used to maintain this risk matrix. So high probability and high impact is a red zone, they are critical. Then medium is yellow and low is the green. So then this help us to visualize in the risk the chart that which risk need more attention. Which risk needs more attention in this regard. So this is. Then step 6 is to prioritize the risk. Sort out the risk from most critical to least critical. Sort out this. And then you document the result. So write the probability, impact, score, and priority in the risk register. So that need to be done by proper documentation. What are the type of risk analysis? One is the simple and first method is qualitative risk analysis, simple and first, and word-based scale, high, medium, and low, and the risk matrix we use, and expert judgment. Then the quantitative risk analysis, deep, numerical, use statistical methods, Monte Carlo simulation, expected monetary values, EVM, and decision tree methods. These are the very well-known methods for using this. And quantitative risk, this gives you this analysis. And what is the output of the risk analysis? First one is prioritize the risk list, and then risk matrix, and then a risk score, upload in the risk register, updated risk register, input for risk response planning. So this is the simple example of risk analysis. The supplier may delay the material delivery. So probability is very high and impact also high. Risk score also high into high is critical. So priority is top one. So prepare a backup vendor. If one vendor is not supplying that material, we can go for another vendor. We can prepare to backup another. And then risk, the developer might take leave for 1 week. Probability, the medium, the impact is low. So the risk score is equal to medium into low. With low priority, decision, we can accept that. Summary is that risk analysis is the understanding which risk matters most, and it rating probability. First one, rating impact, calculating risk score, creating risk matrix, prioritizing the risk. It helps the project manager to focus on the major risks and plan responses correctly. So this is the risk management. And risk analysis process. So we have already discussed this one. It start the process, identify the risk from risk register, access probability each risk, and then access probability for each risk, determine risk level, prioritize risk register and analysis, and then proceed to risk response. And risk identification, maybe we'll stop here for 15 minutes, then we can start around 3:48. We'll start. किस टाइम खुशी क्या कर रहे हो आजकल? हाँ हाँ हाँ, कुछ पढ़ाई पढ़ाई कुछ करता है या नहीं? ऑनलाइन में किसका क्या है इंटर्नशिप? हाँ, और तुम्हारा सिविल का? मैं जो लास्ट टाइम एक जो वाटर टैंक बनाया था ना उसका, now we are going to, we are half of the this one is the implement. Hmm. तो हाफ इस बार तुम एक 6,000 स्क्वायर फीट का एक ये बनाओ तो गौशाला का सेट बना पाएगा ना? है? उससे इजी है सेट। 6,000 पढ़ो, नहीं आता है तो देखो कुछ, आजकल मटेरियल सब कुछ मिलता है। देखिए ये कर, ठीक है? तो इसको थोड़ा करो, मुझे भेजो, मैं देखता हूँ। और प्रभुपाद बुक पढ़ते हो? मैं देखता हूँ। पढ़ो रेगुलरली, मुझे अपडेट करना क्या क्या सीखता है एक मैसेज में। सर आई हैव चांटेड 8 राउंड या 10 राउंड या 16 राउंड, read Prabhupada's visible, these are the main points, but I daily तुम नहीं तो घर में सोओगी और खेलोगी और इसी टाइम पास। हाँ, और पापा मम्मी सब लोग खुश है? ठीक है। कौन घनिष्ठा का जो प्रोजेक्ट क्या डाउट और जो मैथ? वो लोग आजकल मजा में है। उनका भी छुट्टियाँ, तो मेरा ही छुट्टी नहीं है कब। हाँ, और मैं तो मंडी गया था, मंडी से अभी आया, फिर कल जाऊंगा फिर पैरामदूर। मेरा गाड़ी चल, तो तुम कब आओगे? जुलाई में? ठीक है, तुम तो खेल लो। और तुम कॉल किया, अच्छा क्या, मुझे बात करना था तुमको, लेकिन मैं भूल जाता था। हम्म, तुम पता नहीं क्या कर रहे हो क्या। तो ठीक है, तुम अभी ये करो पढ़ के, मुझे डेली बताना, और थोड़ा प्रभुपाद के लिए आधा घंटा एटलीस्ट, ठीक है? ठीक है, टेक केयर। हाँ, मैं धनेश का भी बोल, हरे कृष्णा। ଥଣ୍ଡା ହେଇଯାଇଛି ହାଁ ନାଇଁ ଆଉ ଚଲା ନା ବନ୍ଦ କର ଆଜି 3 ଘଣ୍ଟା କ୍ଲାସ ହଉଛି okay we can start from here to now uh, so risk identification in the AV projects. So this one is we have seen this is the first step, finding out what could go wrong in the project. In the EV project, risk comes from several areas. One is the technical risk. So technical risks are that we uh, there are different components while developing the technical part. One is battery technology issues, and like a thermal runaway, degradation, or failure. And the second one is the charging system compatibility. This mismatch between standard uh, AC uh, this AC DC voltage level, like in India we have one level of voltage, and charging structure also chargers, and in the other place also different kind of this. So one is, this is called the different chargers, AC DC level, voltage levels. And also there are power electronic failures like inverter, BMS, motor controller malfunction, other things that also come. The inverter and software glitches like the problems in the vehicle control algorithm or the communication protocols that need to the that glitches also come. So sometime like in our computer also some glitches come, you need to restart the things and then it is doing the fine. So the risk identification in the project, first one is the supply chain risk. For example, the battery material or the shortage of semiconductors like wide band gap devices that we are not getting now. So like lithium, cobalt, etc., we don't get battery materials, and shortage of the semiconductors also, and dependence on foreign suppliers. For example, magnet, we are dependent on China, so we depend on the Chinese people for the magnets. Then delay in component delivery affecting production schedule also. The components they may deliver late. So that will also create another problem. Then financial risk are there that finance that is the due to cost overrun, due to material price increase, and that will affect on the this will sometime affect on the cost overrun and high cost price. So high R&D cost, then in the prototype, whenever we are doing the prototyping, etc., so there is a high R&D cost also, it is associated. Then funding uncertainty. For example, if you get funding now, you may not get fund also further also. So first installment you may get, next installment you may not. So there is a funding also uncertainty that or sometime somebody wanted to fund you and then he withdrawal. Sometime funding he has given and he has withdrawn your funding. So this These are the funding investors. They withdraw sometime that, oh no, the progress is not proper, so I'll not pay. So like that happens, funding uncertainty. And regulatory and environmental risk. For example, the government policies are changing, and that emission level or the other things, they are changing day by day, and which is come in the impact of the environmental as well as the regulatory risk. Then certification delay, like ARIS and AIS standard compliances, like in they it requires a lot of time actually, the certification, and before you put into the market, so certifications, and they are then the environmental impact, the like battery disposal, recycling is another problem, and this also come under that. Then market and customer risk, the slow market adaptation due to the range uh, anxiety or high cost. So if like in the Mahindra and Mahindra, they show that 400 kilometer per charge. So once you charge 400 kilometer, so at what speed it is 400 kilometer? At which speed it is 400? At which speed it is at 400? So if you see 400 kilometer per charge, if you go very high speed and you generate a lot of torque, so more power with dump. So this may not, your 400 kilometer range may not. If the range anxiety comes, then it is very difficult to take a always EV. They are now very doubtful and fearful where to keep, where to charge, how to charge, what is the detail. Many times we are, and so that is why, or sometimes it is a high cost. For example, a Toyota, we have a hybrid car, and the cost of that car is, I think, around 27 lakh rupees. So if you see, for a common man or simple man, 27 lakh car, okay. So the cost is a hybrid car. The cost is 27 lakh rupees. So it is very high for a general people. Mm. So the cost, this hybrid car or electric car, actually, they are very high costly. Actually, you know that the even Tesla also, Tesla car also, it is very high costly. That is what always slow market adoptions. It's not that quickly, although government is telling many policies that we will, the government is telling, but there are a lot of, mhm, so uh, this, that is a lot of policies that need to be. Then competition, if you see that the established uh, the established auto market automakers, they have already a new entrance. So those who have establishment, they have already the market. Everybody know the market values now, and they also take us to this new entrance will make us more discomfort in the. So those who have a market, they are going and they are replacing with ICs to the electric EVs, and entering into the market as a new entrance is really tough challenges. Rapid tech obsolete, like and the new battery chemistry makes tech outdated. So new system comes and new system we are implementing and new standards come. So which make more rapid adaptation, a rapid test, take absolute. Quickly it is swapping like uh, the technologies are swapping from one technology to another technology, and that is going on. Then project management risks are the poor coordination among cross-functional teams. For example, you have a technical team, management team, and implementation team, testing team, and then standardization team. If these six team, they are or five team, they are not properly coordinating, then project will take more time. There is a lot of risk. Why? Because coordination is important, because one component is you have developed, and when you come to next component, that same component you will not repeat. What will be new, that is coming. And then poor coordination between cross functional teams, that how you have connection between each other, and unrealistic timeline. Okay, that I remember there was one project given by one company to me, and that company told me, "Sir, this project we want in 2 months." Uh, so I thought that 2 months, 2 months, no project can be implemented actually. So I asked him some more. He told, "No, sir, 2 months only maximum. We give." So this is what the unrealistic timeline. If somebody give you, that is very quickly you have to do it, and it is not possible. Then skill shortage, especially in the EV domain. Nowadays it is people are learning, and slowly they're developing the skill. And once they develop the skill, we can you can so the skill shortage is that whatever job we want to do, when we want to recruit there, say that shortfall will come and will become, you can mitigate if you bring to other. Then risk analysis. One is the qualitative risk analysis, and this help prioritize the risk based on likelihood or the probability function we have, and that uh, that effect or the how likely risk to occur, this one, and then impact severity also, how serious effect would be if occur. And often we represent by using the risk matrix, like impact and likelihood. Low impact and likelihood low, you have low, medium, this is the matrix. And you will see that the high impact high, very high. That means if he project a team that they can give the priority, which is high impact risk, high probability. First, huh? Then quantitative risk analysis involves numerical estimation using data or models. And then what we want, the EMV, that expected monetary value, is equal to probability into impact. So impact is in rupees. Sensitivity analysis test which factor most affect project cost or timeline. Sensitivity analysis do with the project cost or timeline analysis. And Monte Carlo simulation, that is the probability difference project outcome. And then example, there is a 30% chance that the battery cell cost rise by 5,000 per pack. So EMV is equal to zero 0.3 into 5,000, which will be 1,500 risk cost per unit. So this way we can just find out what is. So what is the output of risk analysis? One is the risk register, where you can identify which is most dangerous risk, and the probability when it will occur, and what will it impact, and who is responsible, and how to mitigate. These are there in a risk register that will be given to you. Very nice. So risk response plan, how to avoid, mitigate, transfer, or accept each risk. So how to mitigate? The risk can be avoid also, or it can be transferred. Okay, that or accept each risk. Risk identification and analysis is that early detection of threats that will give you the better decision making. Then reduced project delays and cost overruns. Then improved vehicle reliability and safety. Improved vehicle reliability and the safety, that is also will give you. So the project risk, simplified EV project risk case. So this is one of the example of risk identification. For example, battery overheating, their risk, delay in BMS firmware development, then EV charger supplier delay, policy change reducing subsidiary. What are the probabilities? Medium, and then impact is high, risk is high. So add thermal management plan and redundant safety sensors, and delay in the BMS firmware development is low risk, risk level is high. Increase developer resources and parallel testing. And EV charger supply delay, and if you see that risk level is high, and that is identify secondary suppliers. So this way you can uh, that- so strategies for risk mitigation and management. One is defining possible problem early, checking how serious they are, and planning how to deal with them. Common say avoid the risk by changing the plan. We can reducing the risk by improving safety or quality, and transferring risk through insurance or partners, and accepting the risk if small or unavoidable. So this is the common strategies for mitigation of the risk. So what are the important focus area? The important focus area is this, managing the supply chain as well as technological risk. Okay. And then ensuring reliable charging infrastructure wherever you go, you can charge your vehicle or not. Then risk mitigation and management. This uh, they identify the risk, what can go wrong, and then analyze each, how likely, how bad it is affecting, and prioritize them. We need actions. You may move forward with mitigation based on the priority, high probability, high impact at the first. Then develop a response plan, that is called the five core strategies. Then when you decided to act on a risk, and you should always think like it is a positive risk response, and but different intent. Mm. So what to avoid, what it is, change the plan so the risk cannot happen. Why use it when risk has unacceptable impact and you can remove the cause without killing the project. So the when the risk is unacceptable impact, and you can try to remove the cause, okay, without this. How to do it? Basic step: identify the root cause of the risk. That is a particular risk subcontractor. Hmm. Identify root cause of the risk. Change the scope or methods or schedule or approach to remove expose. That is use internal resources. Delay a start unit until condition improves. Then choose a different technology and re-evaluate new plan for introduced trade-offs, that is cost and scheduling, etc. Then record the change and close the risk in the risk register For example, a bridge contractor is unproven. Avoid the risk by selecting pre-qualified contractors instead of using the risk board bidder. So to avoid avoidance can be expensive. or reduce opportunity. Use when the cost of the risk happening is higher than the cost to change the plan. Then mitigate, reduce probability and impact. What it is, take action that make the risk less likely or less damaging. So whenever we are taking the action, you see that risk is managed, okay, and that is not affecting, or we can make them that the risk can be avoidable, okay, the less. And most common strategy that you should use, the reduce exposure, okay, keeping plan mostly intact. What are the basic steps how to do it to mitigate? Define clear measurable mitigation action, and what to do, who will do, and why, by when. And break action into short term quick wins and long term goals. Assign owners and resources, people, budget, tools. Put trigger thresholds. If you indicate X occur, take action. Why? Like that. And monitor effectiveness, refine if necessary. Mm. So, monitoring the project in each stage is also very important. So, what are the typical mitigation technique? A redundancy, like spare part, backup server, etc. Add redundancy. And prototype or pilot to de-risk technical unknowns. De-risk or prototype uh, technical unknowns. Increase the testing. That is quality assurance and stress, etc. Increase the testing. Okay. Then train staff to reduce human error. So always there should be continuous training to all the staff members. And then tighten procurement requirement and set penalties for late delivery. So the you can set penalty for late delivery like in IIT, but when you put this set penalty, they may not, because very few vendors have the specialization of supplying, and when you put this one, the late fine, they generally don't give anything back. So sometimes the vendors, when you require, they don't come. So that is why you cannot always say that we can put penalty for delay. No, even if delay, you have to accept it. And stage deliveries, that is phased rollout rather than big bang. So that is how we, and the it remove a risk entirely, reduce consequences or likelihood. Then transfer or shift the risk to third party. Like you shift to third party. For example, you have some limitation in the testing on the thermal bench, other things you want to test, and without any load. Without any this. That is why you can move responsibility for the risk to someone else, usually via contract, insurance, or outsourcing. If you give contract to that part of this one, for example, that we are building a beautiful some institution. So when you go, there is a lot of problems. When others they go, there is no problem. So like that, contractor can be given, or you built it, or did you do here? The contractor will tell. And also insurance also will give some benefit. If you are developing a car and car got crashed to somewhere, and if you have insurance, you can. And then outsourcing, if some experts are not there, you can outsource those experts and use it for temporary time. Again, you can give back. That is it. And use when another party can manage the risk better, or when your organization want to limit financial exposure. How to do it? Identify which risk are transferable. कौन सा risk we can give them, and to do very quickly. One is often the cost, legal, and delivery. Then select the transfer vehicle, contract clauses, and then warranties, performance bond, insurance, like that. And draft clear contractual terms, responsibility, etc. That can also. And then performance metrics, penalties, and indeterminates. Verify the parties' capability to accept the risk. One is financial strength and track record. So verify the party's capability to accept the risk. And monitor compliances and keep contingency plan. Do not assume transfer, eliminate your oversight. So that not like, oh, I have given this work to him, so he will do, and you should be very free. Oh, now I have given him, let him do, finish it. Not like that actually. So that is why that also we have this very important thing is the planning. Actually, it's not that you have given to somebody and they will do that. No, you have to also responsible for that one. Okay, and that way it is also will give you to more lot of uh, a lot of securities in this. Then uh, then accept, acknowledge a risk, no active response. And what it is, decide to live with the risk. Often because it is low impact or mitigation cost more than the risk. And what to do? This is the impact if or less impact or mitigate the cost. Then why to use it? The cost of action exceeds the expected loss. And when the risks are minor or unavoidable, you should use it. Then how to do? Document why you accept it and set the acceptance criteria. And assign monitoring and define indicators that would trigger reconsideration, provide contingency reserve, time or budget if necessary. Resist periodically. Acceptance is not permanent if conditions change. So, the acceptance should always be recorded with an owner and monitoring plan. It is a conscious choice how to accept the record, the owner and monitoring plan. Then for positive risks or exploit mean ensure it's happen, enhance increase probability or impact. What that means the opportunity, whatever opportunity, that means that whatever opportunity you take, you think that it is going to happen that. And why to use it? To gain upside, for faster delivery, cost saving, and for market advantage, because this will give you more opportunities for the development as well as marketing strategies and for generation of the cost or generation of the generate this. So generate the market visibility as well. So what are the basic steps? Identify action that will make opportunity happen. Allocate more resources to a successful pilot. That means who is able to do many the successful the design or the successful development. So we should give the more and remove barriers to the opportunity. There should not be any barrier. For example, sometimes we see that there is the oil is used instead of this oil. So sometimes we get this little barrier. So this remove that opportunity, capture the gain explicitly, and also the contract terms, IP protection, etc. Then monitor and the scale. So what are the implement response that create an action plan, and that the task list, deadline, owner, cost estimation, etc. First one is the assigned role clearly. Who is going to execute, who will monitor, and who approves. So when you don't assign the role clearly, then there will be lot of chaos actually. Who will do? And then allocate resources like time, money, and tools. So allocate resources to each department. Okay, each point. And then communication to stakeholder, what will change and why. So you can communicate whatever you are changing in the project, you want to make it, and that will change and why. Set KPIs or trigger point that show whether the plan is working, okay, and execute and record progress in the risk register. Then monitoring control, when we have the monitoring control is that the keep checking, okay. So where many projects fail, plan are made but not checked. So monitoring must be active and structured. How to monitor? Basic checklist. Regularly update the risk status in the risk register, like weekly or twice in a week. That regularly you must check. And then track indicators And threshold, like lead lag indicator, you can track this. And recessive probability and impact after mitigation. Risk, when you mitigated the risk, what will be the impact? And whole periodic risk review meeting with owners. So then use dashboard for critical risk, visual red, yellow, green, which I have already discussed. Document any risk event and response effectiveness. Trigger the contingency plan immediately. Then escalate per government rules if impact is severe. Capture real event detail, root cause, timeline, and cost. And recover and resume. Then conduct a post event review. Issue management and escalation when things go wrong. So, a risk is a potential problem. An issue is a problem that has happened. So, how to handle it when there is a things which is goes wrong in this? So, log the issue, the time, owner, and the impact. Then assess severity and assign priority. So, what is the severity of that one? So, according to severity, we give the priority. What we can do that. From a response team, if needed, form a response team who will give answers and also questionable and try to mitigate that. Apply contingency or ad hoc fixes. Communicate to stakeholders. Escalate to sponsor if needed. So, update the risk register. The risk may be closed or recategorized. Review and lesson learned. Close the loop. After action or incident, you conduct a short lesson learned session. So, after each session, you will understand what worked out and what did not. That can be monitored or that can be discussed. And then update template, a checklist, and organizational lesson repository. What are the difficulties and how it is tackled and handled. And that is the very important thing, that why it is. The repository means for this will be helpful for next project as well. Improve future mitigation, like better trigger, clear contracts, and training. And close resolve risk. The which is the risk is resolved. You can close that. Keep residual risk open for monitoring. Those who are residuals, you can monitor that. And for practical risk register field, if you see that ID discussion category, you can put in the probability is a high, medium, or low, impact also high, medium, low. And then score priority is that what is the score. And then response is mitigated, avoided, transfer, except exploitation. That is why the simple trigger example, vendor misses 2 delivery milestone and it is escalated to the procurement director. Defect rate is greater than 5% due to quality assurance. Free release and start rollback plan. Then building budgeting for the risk, contingency reserve for known risk. So you must keep some contingency plan if the risk is known to us. Management reserve for unknown unknowns. So if there is some management reserve unknown, then companies share top 5 risk in weekly status report. Key sponsors informed for critical risk. And common mistake, making a plan and forgetting it. You plan it and we forget it. That means you give the energy to the vehicle and you forget where it goes. You don't know it where it goes. And then ignoring low probability and high impact risk. And blindly transferring risk without oversight. And then no trigger defined. Set clear measurable triggers. Poor communication, including risk status in the stakeholders meeting. Communication is very important, and we'll read in detail how to communicate, what are the communication protocol, what are the communication limitations. All these things we will discuss in the later slides. So, final checklist before you finish a mitigation plan. If the response matched to risk severity, yes or no? Is a single owner signed or measurable trigger and KPI defined, and then are resource allocated, and then the is there a contingency plan if response fails, and is it recorded in the risk register and communicated? And then the project risk management matrices, and this can be created